In this video, I'm going to be going over challenge number 14 of Damn Vulnerable DeFi, the Puppet V3, which is the sequel to Puppet V2, which is the sequel of Puppet V1, which covers some Uniswap V3 protocol intricacies. And yeah, let's get into it. So even on a bear market, the devs behind the lending pool keep building. In the latest version, they're using Uniswap V3 as an oracle. That's right, no longer using spot prices. This time the pool queries the time-weighted average price of the asset with all the recommended libraries. Uniswap market has 100 WETH and 100 DVT in liquidity. The lending pool has 1 million DVT tokens, starting with 1 ETH and some DVT. Pass this challenge by taking all the tokens from the lending pool. And we also will need to set a valid RPC URL in the challenge test file. So let's go ahead and take a look at the code. So we're given a contract called Puppet V3 pool. As always, let's just go through the functions and the variables that it has. So we've got a deposit factor of 3, a TWAP period. We're going to find out that this stands for time weighted average price period. The token WETH, the token like for DVT token, and also a reference to the Uniswap V3 pool. We've got a mapping of deposits, an event, and in the constructor, we just set up those addresses for the other contracts. So we have 3 or 4 functions here. This main function here is really going to be the one that we're interested in. It's the borrow function. So we borrow with a borrow amount. So say we want to borrow 10 DVT tokens. We need to get the deposit of WETH required. So this calculates the deposit of WETH that's required. It'll then transfer that from the sender to the address. And then if that all works, do some accounting and then do a safe transfer of the borrow amount to the sender. We have 3 other functions here which kind of help with this borrow function. Calculate deposit of WETH required. So this is what is called from the borrow function. This gets a quote for the amount that we're looking for. The get oracle quote multiplies it by the deposit factor, which is 3. So again, from that borrow function, we need to basically provide 3 times the collateral to borrow that amount of DVT, according to whatever the price is on the Uniswap pool. The get oracle quote then calls this function, which actually calls the oracle library. And the oracle library is just a helper library in the Uniswap V3 periphery repository of contracts. So this will consult with the V3 pool that we provided and over that TWAP period, which is that time-weighted average price period. And I'll go over a little bit more of that when we're going over the exploit. Then once we've got that arithmetic mean tick, again, we'll go over that, what that is, we get the quote at that tick. So we're looking for how much this price is, again, as opposed to a tick, and we return that back to the borrow function, which then makes sure that we have enough WETH required when it does this transfer. Hi, so one quick thing I forgot to cover here was the toUint128 function. So as you can see down here, that function is going to translate the amount from a unsigned int 256 to an unsigned int 128. Now, the reason that it kind of isn't just directly done in code by directly casting it is because the way that that function works is it takes the least 128 bits least significant 128 bits of that number. So what you could do if this function didn't exist is actually have the 129th bit be 1 and then the rest of it be 0, so that when it did the translation, it would get a quote for 0 instead of the 0 or like 2 to the power of 129. And then you could take all the deposit that way. But in this case, it is done safely because it's checking that the amount is equal to the new amount, which is being translated from uint 256 to 128. So just wanted to cover that. This is the contract. That's everything in the contract. Let's have a look at the actual setup of the challenge. Now, before the challenge started, I did set up just the RPC URL, so I didn't have to share that in the YouTube video. So I've just got a little JSON file here that this file imports to read that RPC URL. So what is happening here is we've got some constants here. It'll do a fork of mainnet so that all the mainnet addresses and everything and all the balances are forked from mainnet. We get a new player wallet with this particular private key. We set the balance to the initial balance, the same with the deployer wallet. It then gets a reference to the Uniswap V3 factory contract. Now, if you look this up, this is the actual mainnet address of the Uniswap V3 factory. So that's good to know. Again, a reference to WETH, and we deploy some WETH to get that into the deployer address. We get the token, deploy the token, and it then deploys a new contract called this position manager. And this position manager creates the pool for us with a token of WETH and the DVT token, the fee that is hard-coded of 0.3%, and the initial price and the gas limit as well. We then get the pool, have a reference to that, and we increase the observation cardinality of this pool. I'll go over that in a little bit. And then it adds some liquidity to the pool. So there's actually some liquidity, deploys the lending pool, and transfers the tokens to the player, increases the time since the liquidity has been there, so for 3 days, and then it does these calculations to make sure this is all looking good. So if you've watched the previous 2 Puppet videos, you'll know that essentially what we needed to do is heavily devalue the DVT token in relation to the WETH token, and once we've done that, we can then use that new price to then try and borrow from the contract, which will then, because of the heavily devalued DVT token, we get a much, much better price for our quote, and we can then borrow everything that is in the pool with only a small amount. Now, this is pretty much the same thing here. The exploit that we're going to do is pretty much the same, but there's 2 main differences. The 2 main differences are, one, we're using the Uniswap V3 protocol. Now, I'm not going to go into all the details of what the difference is between Uniswap V2 and Uniswap V3, but the main difference that you need to know is that between the two different protocols, one has a smooth curve of liquidity and the others have concentrated bits of liquidity. And you may have heard this before if you looked into V3 before. It's this concept of ticks, and every single price point can be fit into one of these ticks, and they determine what the price of the one token is related to another. So the other bit of that's different in Uniswap V3 is we're using this time-weighted average price. Now, in the previous challenges, when we changed the price by submitting a transaction by doing a swap, immediately afterwards, the price has changed because we now have the reserve ratio between the 2 tokens is heavily different. In this case, it's actually using a time-weighted average price. Now, again, this is coming from this consult here to get the arithmetic mean tick. And what I recommend, if you do want to read more up about Uniswap V3, is you read this introduction to Uniswap V3 development book. It's really, really good. It gives you an overview of how everything works, how the swaps work, how liquidity works. There's a lot of math involved. You don't really need to go super deep into it to understand everything and how to understand this. But the main thing to understand is this price oracle. So in milestone 5, what is a price oracle and how is it calculated in this in Uniswap V3? So the way that these price oracles work in Uniswap V3 is, again, using that time-weighted average. So every time that a swap occurs, a new observation is created before the swap occurs. And what it does is it checks from the previous observation to see how long it's been since the previous observation, and then adds what's called to its tick cumulative, the amount of seconds multiplied by that tick that it was before the swap. So you can imagine that initially the observation would be a tick of 0 because, again, the way that Uniswap tick prices work, it is 1 basis point, which is 1.0001. So to the power of whatever tick that you have. So a tick of 0 is going to be a price of 1 to 1, essentially, because anything to the power of 0 is 1. As we go up, the price will increase, increasing by 0.001% every time, or 0.1% every time. And in reverse, it reduces by 0.001% as well, or 0.01%. So what happens is when we take that observation and we perform a new swap, we take a new observation, depending on how long it's been since the previous observation, we then multiply that by that tick price, which then weighs the price heavier towards that previous tick price because it's been there for a bit of a longer period. So then when the next swap occurs, then a new observation is created. And then that observation, compared to the previous one that we did before, again with the previous tick price, is calculated. And so over time, we get this new tick cumulative. And what we want to do is have a look at the previous period. In this case, it's going to be 10 minutes. Again, looking at the contract itself, we can see that the time-weighted average period is 10 minutes. And so if we immediately do a swap, then the new price is not going to have any weight at all because it hasn't had any time since that swap. If you do it immediately, it's only going to take the previous 10 minutes of data into account when it does its consideration. Now, I'm not going to go into the details of how Uniswap V3 specifically does this. I'd recommend, again, looking at the Uniswap V3 book and also looking at the source code of these contracts. One more quick thing here. I did write up an article around how this particularly works and all the mathematics behind it in a blog that I've posted on my website. So I've linked that in the article below. If you want to learn more, if this explanation wasn't that clear, please check the article and hopefully you can read through that and learn how to do it that way. So after it's done its calculation, it'll then come back and give us this new quote price. So how do we actually solve this challenge if this is the case? And the reason that this TWAP period exists is because it stops and mitigates against times of high volatility. So if the price is going up and down really, really quickly in a matter of seconds, you don't want that to be your quote of what you think the actual price is. If you take an average over the last 10 minutes, weighted against when the previous observations were, then that's when you'll get a bit of a better, more understanding of what the price is, as opposed to the current spot price looking at the two reserves. The other thing that I wanted to talk about was the cardinality. Now, this is all stored in the Uniswap V3 pool contract. Now, the cardinality of that contract is essentially the number of observations that can be made and stored in that pool. So you'll see in the setup here, when we do the deploy, we can see in the Uniswap pool, we increase the observation cardinality. Now, usually, I'm fairly sure, actually, we can look this up in the Uniswap V3 book, that the default cardinality of any Uniswap pool is 1, or maybe 2, something really, really small. And so the history of the observations is obviously very short and gets overwritten every time that we run to the end of that array of like when we're going through the cardinality. Again, if we go through the pool here, we have a pretty good kind of diagram of how this works. If we've got 5 observed prices, there's more empty observations, we can write to the next one. If they're all filled, then we go back to the start and go again. Again, please read through this if you want to learn more about how this works. But in our particular case, we only have a few observations that are required. So when the token is initially deployed, we have an observation there, then there's liquidity that is provided. So again, a new observation is created and through this mint function. And then what we're going to do is we want to actually do our swap. Now, when we do our swap, remember, it's not going to actually do anything for a couple of minutes, like initially, unless we wait some time. And then the new swap price will be created, or like the time-weighted average price will have more weight on the new swap price that we have created. So again, the reason why we can do this is because if we look in the setup, the Uniswap pool only has 100 WETH to 100 DVT tokens, and we have 110 tokens. So we can really change the balance of this Uniswap pool. So let's go ahead and get into the code and we'll kind of walk through it. So the first bit, what we're going to do is, as always, we're going to connect to all the relevant contracts as the player account and have this log just so we don't have to type console log every single time. We're also going to implement this helper function, which can show us the balances as we go through the exploit and address. So this is just going to, take a name and an address and then start printing out the DVT, the WETH, and the ETH balances of that contract. The next thing that we're going to do is, again, provide another helper function and also initially log the balances of the player. So if we start this and run it, if we go yarn run puppet v3, we should see that the player address should have 110 WETH, 110 DVT. It should have 1 ETH and no WETH, I believe. So yep, that's the initial balance of the player. This get quote function is going to, instead of directly calling borrow, we're going to get the exact quote that we need from that calculate deposit of WETH required and return that back to our function so we can use that later. The next thing that we need to do is, in the previous Uniswap or Puppet challenges, there was a Uniswap router. And the Uniswap router is a really handy contract that will take in a swap request and automatically route it to the correct pool that it thinks it should go to, and also do a whole lot of calculations and stuff that we don't need to worry about it. Interacting directly with the pool is a little bit less user-friendly than interacting with the router. So I'm going to directly interact with the router because it's much easier to do, and we don't need to go into the depths of working with the pool directly. So what we can do, again, because this is forked off mainnet, is we can actually just grab the mainnet address of the router and connect to the router at that mainnet address using a new Ethers contract. The way I got this Uniswap router address is going to Uniswap's actual website, and you can see all their mainnet testnet addresses for all their different contracts that they have. So the swap router 2, there's also just the regular swap router. I think you can use them for both. I'm not too sure. But in this particular case, I'm using the swap router 2, which is, I think, the latest swap router. So we've got that here. Then after that, we're going to approve the Uniswap router to take all of our tokens. So because what we're going to do is we're going to provide all the DVT to retrieve as much ETH as possible, or WETH as possible, from the contract pool. We want to approve the router to then do that swap on our behalf. We then can perform the swap. So when we perform the swap, we're going to do an exact input single. This is opposed to exact output single. I think I covered this in the previous video. So the difference is we're going to provide exactly 110 DVT tokens, and please give us back as much WETH as possible, as opposed to exact output single, which is please give us exactly, say, 100 WETH in return, and take as much as you need to get to that output. The important bits here are the address and the address of the token and the address of the WETH. The order of this will tell the contract or the routing contract which ones you're actually providing and which ones you want to get out. This 3,000 here is actually the fee. So a Uniswap pool is unique by its 2 tokens and its fee. The player address that's going to receive the tokens, and the initial token balance. And I'm not sure what these ones were for. Maybe the minimum and maximum settings for the square root. Price, again, this is why we use the router, so we don't need to worry about this. Then once we've created that swap, if we do check the quote, we'll notice that it's still 1-to-1. So I'm going to go ahead and actually show you this when we do this. So we're going to do get quote is here, and I'm going to make sure this prints it out. So I'm going to add true here. Again, this was the helper function that I defined up here, this get quote. And we're going to see that when we do this, that the quote is still going to be 1-to-1, as in, if we wanted to provide 1 million, we want to get 1 million tokens from the lending pool. Again, that's what the whole idea of the challenges. Then we need to provide 3 million WETH in collateral. So we obviously don't have that. So I'm just going to show you that's what it is here. Then what we're going to do is increase the time by 100 seconds. Now, the reason we're doing it by 100 seconds, it seems a bit arbitrary. If we have a look at the success conditions, there's 3 main ones. The first one is there can't be more than 115 seconds passed since the last block timestamp. And the last block timestamp is basically as soon as the setup is finished, it gets the initial block timestamp and then compares it to the current timestamp and ensures gets the difference in seconds, and then that's going to be less than 115. So the reason I chose 100 here is because we do need some transactions like the approvals. We're doing quoting as well. I think that's actually not an actual transaction because that's a view transaction. But what that'll do is it'll increase the block count by a little bit. So if we just do 100, it should give us 15 seconds of buffer, which should be fine for us to actually go ahead with to reduce that price using that new weight from the new swap price that we've provided. again, because we're providing 110 DV tokens, it's going to pretty much empty the WETH in the pool. So it's going to heavily devalue it, like we did in the previous challenges. And then the other two success conditions are to make sure the token balance of the lending pool is 0 and the token balance of the player is the token balance of the lending pool or greater. So once we've increased the time by 100, we can then just go ahead and get a quote for the new price. So once we get this quote, actually, I'm going to run this now just so I can show you this working. So we go ahead and run through. Still loading. Sometimes it takes a little while because it has to read all the data from mainnet using the router JSON isn't defined. Oh no. I need to install the Uniswap router. So the other thing that we need to do in this case is actually install the Uniswap router. So if I do, actually, sorry, it's yarn add Uniswap router contracts. This isn't added by default in the Damn Vulnerable DeFi repository. So you just need to add that, and then that's going to add the JSON file to read the ABI file so that ethers can then interact with that contract. So router JSON is still not defined. Oh, right. Okay. I actually need to import it. Okay. So I'm just importing it here. So router JSON is going to require this specific swap router to JSON, which is in that dependency that we just installed. And then that's going to be used now in our code. So let's let this run. And from here, we can see, let's have a look. So this is the initial player balance, connect to the routers. From here, we then swap all player tokens for as much WETH as possible. So we still actually have 10 WETH left. So we actually get 99.999999 WETH. Again, it's 100 to 100. So if we're providing 110, we may not be able to do that. So we've just gone to the end of the liquidity, essentially, and then stop there. And that's why we haven't actually used all 10. We also have a little bit of ETH because that was used from gas from that one. And then the new balance of the Uniswap pool is 200 DVT. So again, we provided at just over 100, and there's just like a tiny bit of WETH and no ETH. So again, we're here, right? So this is where we just log the new balances right after the swap. When we do our new quote, because there hasn't been any new time, we can see that the quote of 1 million DVT is still 3 million WETH. So obviously we don't have that amount. However, when we increase the block time by 100 seconds, we get the new quote and approve the lending pool for transfer. So the new quote of 100 million or 1 million DVT is now only 1.1 WETH, which is much more close to what we can do. So after that, we can just then go ahead and borrow the funds. So we can grab this. Again, if we do another quote, right? Because we're doing this twice. Ooh. If we do another quote directly afterwards, you'll see that slowly the price will go down and down and down. And the reason behind that is every transaction we make is a new block, which means a new second that passed. So if we have a look at it now, it's going to be just less than 1. And if we do it again, it's going to be just less than 1. And the longer and longer we do it, the heavier the weight that new price is going to be. So we can get rid of this quote because we don't need it. We can approve for this much to be transferred from our WETH balance. And let's actually go ahead and borrow the funds. So we've approved how much we need for the quote. We start to borrow the funds, and then we're going to log the balances afterwards. So let's see how this goes. We should actually solve the challenge here. Here we go. Yay, we get the tick. So again, if we kind of come down here, the quote of 1 million DVT is 1.1 WETH. Again, we only have a little bit of WETH anyway. So actually, no, we've got 10 WETH, 100 WETH essentially when we did that transfer, right? So we still could do it with 1.1, that's fine. But afterwards, once we've borrowed the funds, we've got the million DVT, we have 100 WETH, and the ETH is still just a little bit because we use gas. And now if we look at the lending pool almost has nothing. So that's the challenge. That's how you solve it. Again, it's really about devaluing the actual DVT token, but it's just using the Uniswap V3 protocol. I really dug deep into this and learned a whole lot about the Uniswap V3 protocol when I was learning about this, and a lot of unnecessary stuff, but I eventually got there in the end. But yeah, that book, the book of Uniswap V3 development, I can't recommend it enough. It is super, super good, and really, really kind of able to be consumed quite well. It's not too crazy with the mathematics or anything like that. And it kind of goes through how Uniswap V3, you can build your own Uniswap V3. So yeah, that's awesome. And so I hope you guys enjoy the video, and I'll see you in the next one.